Question 1 from Tutorial 3. Here is our differential equation. dy dx equals x plus 5y. We are going to use the method of integrating factors that we introduced previously. First step, we rewrite our differential equation. We will shift the term involving y to the left hand side, so we get this. This is of the form as given down here. f1 equals 1, f2 equals minus 5. We don't need any special conditions because f1 equals to 1 and therefore is always non-zero. So we can divide throughout by f1. We don't even need to do that since f1, our differential equation, is of this form. The next step is to introduce integrating factor. We start with f2 and we integrate it. Integrate minus 5 and that gives us minus 5x. Again, I would like to note here that we are not going to introduce our arbitrary constant c at this stage. We only put it in at the later stage, which we'll see in a moment. Okay, so we have integrated f2, then we need to multiply throughout our equation by exponential of the integral of f2. That is e to the minus 5x. That's what we have over here. We multiplied everywhere by our integrating factor. Notice minus 5 times e to the minus 5x is exactly the derivative of e to the minus 5. The product rule tells us the left hand side can be expressed as d of dx of integrating factor times y. The right hand side is x times e to the minus x. Next step, we integrate. When we integrate the left, using the fundamental theorem of calculus, we get this. E to the minus 5x times y. What about the right hand side? For the right hand side, we need to make use of integration by parts to solve it. If we do that correctly, we should get this formula. Minus 1 over 5 times x times e to the minus 5x minus 1 over 25 times e to the minus 5x plus, at this stage, the arbitrary constant c. So we have obtained our formula. Next step is to solve for y. To solve for y, we need to divide our equation by e to the minus 5x. Why is there no problem? Because this is an exponential. It is always positive, so there's no problem in dividing by it. Answer, when we do that, when we divide by this exponential, is given here. Y equals minus 1 over 5 x, these two cancel, minus 1 over 25 with cancellations, plus c times e to the 5x, where c is now stated here as our arbitrary constant. We are done. This is the complete solution, but why? It is because, you see, there are no special conditions, and the exponential is always positive, so there's no risk of dividing by 0. That means this is precisely going to cover all possible solutions. This is the complete set of solutions to our differential equation, and we are done for question 1.